Hello everyone, I'm MURUGAVEL, I'm your tutor. So today we are gonna see a leak code problem on 42, which is trapping rainwater. Okay, so let's directly dive into the question. Given n non-negative integer representing elevation map, where width of each bar is 1, compute how much water it can trap after raining. So this is the simple question actually. You can even understand while reading this one. So let me put the question in a simple terms. So they are giving an array with a bunch of integers. Here each integer in the array represent the height of a building. So let's take here it's 0, right? So which means there is no such kind of building. So there is no building existing here. And before you seeing this graph representation, you should know that height may be vary, but the width always constant, which is given as 1. Okay, so here height is 1, so which means there is a building which unit of height 1, and next there is no building, and next to that there is a building with a height of 2. So this like it goes on. The black color indicates there is a building. So what they are asking is if there is a rainfall takes place, how much unit of water it can store or trap. So here you can see there is a space in between this block, right? So we can say in this particular index there will be a chance of holding 1 unit of water, and this particular solution there is a chance of holding 1 unit of water, and in this index there will be a 2 unit, right? As like in this index there will be a 1 unit of water get trapped, and along with this there will be a 1 unit of water get trapped. So you should know that at end position of the building there is no chance of holding water because there is no building next to it. So even if there is a rainfall occurs, it just fell, it does not hold water. Okay, so we have to return 6 because when you sum up this unit of water you will get 6. So this is our output. We have to hold we can hold a 6 unit of water in this building space. Okay, so this is the simple shortest explanation of the question. Next we gonna move on to its optimal solution along with brute force. So let's directly dive on to it. So let's talk about brute force approach. Before going to this, you just consider that this is not a leak code problem. Just consider as a real-time scenario. Okay, so that you can understand the things very cleverly. Okay, let's get it into one. So what we can do first, we can transfer through all the building, and in each building we can find how much water it can hold. For example, in this particular building it holds 1 unit of water, right? So we just put it in a result as a variable, and we just go to this index, and here you see there is no chance to hold water, but here in this index there's a chance to hold water of unit 1. So that will be some add up with the result, as like we just transfer through this building and we can find the amount of unit of water we can store while rainfall. So this is actually easy, but how we can achieve this one? Because you will know that in this particular index it store only 1 unit of water, right? So for that we need to go with the approach called two pointer. Okay, so this is called a two pointer, just comes under optimal one, but let me explore just the approach here. So for example, if you want to find the amount of water it's stored in this particular index, so here the red number indicates index. Okay, so here 2 index the, so this 2 indicates the index. Okay, so particularly in this second index, the height of 0, that is there is no building, it holds the 1 unit of water, right? How we can find it holds only 1 unit of water? Okay, so for that you have to take two things, that left element to this index and write elements to this index. As you can see from the left elements, the building with maximum height is 1, right? And the rightmost element, the building with height maximum is 3, right? That is this one. So in order to find how much water it can store in this particular index, you have to find its left max and right max. And then you have to uh, take minimum of this. So here 3, 1. So minimum of this is 1. So you have to take 1 and you have to subtract that minimum value with the index we are currently in, right? So index we are currently in is 2. The height of this particular index is 0. That is this black numerals, right? So you have to subtract that minimum max minus 0, right? You have to subtract that one, you get the 1 as a result. So which indicates it holds 1 unit of water. So you can clarify when we see the another example. Here you can see at the index it holds 1 unit of water, right? So for that, what we have to do, we just have to find the left max. From there is a two building left of this indexes. There's two building, one with the height of 1 unit and another with height of 2 unit. The max of is 2. So I'm taking left max as 2 and right max same as 3. Okay. So minimum of this one is 2. And now I'm subtracting with the current height. So currently we are in this index which is 4 and that index there is a building of height 1. So we have to subtract that 1 from 2. We get 1 which states that there's a chance to hold water 1 unit in this side or in this build. So this is only by doing this one, you can find the at every index water it hold, and sum of that one gives the total unit of water it holds. But what is disadvantage with this approach is that we are using n square complexity. Yeah, how? Because we are transversing through each building, which consumes big O of n. Apart from that, we have to find left max, right max for each index. So that includes another big O of n. So we have to come up with that nested for loop, which is n square. In order to optimize, we can use the two-pointer approach. Okay, let's talk on that one. Before going to optimal, you should ensure that you understand the brute force approach. So let's dive into optimal approach. So guys, let's talk about optimal solution. So for optimal solution, I am considering the two pointer, one is left and another is right. So I am assigning this two pointer to the end of the array and I am initializing the left max as -1 and right max as -1 and again uh, to store the result, I am initializing the result as 0. Okay, so the left pointer is here, and as you already know, the right pointer is at the set. So now I am comparing the value of both the things, and here you can see the left pointer value is low or less. So in that case, I will go with the left pointer, and I check that whether the left pointer has the value is greater than left max. No, it's no, right? So in that case I will exchange my left max, or I don't exchange, I will update my left max as the left pointer which is holding as 0. So -1 is replaced by 0 and I will move the my left pointer to next index. And now I will check. Here you can see the both has the same value. So either you go with right pointer or left pointer. So let me go with left pointer itself, and I will check whether this value is greater than left max. Yeah. So I will update my left max as 1 and I will move my left pointer to next index. Now I will check again two pointer, and here you can see the left again having the minimal one. So in that case, I will check whether this value is greater than left max. No, right? So I will go with the else spot. So in that time, I will what I will do is I just subtract my left minimum with the index which is currently I'm in. So the currently index is 2, but the height is 0, right? So what we'll do is the left max is 1. So 1 minus 0 is 1. So that 1 will be incremented to result. So this is going to happen, and then I will move my left pointer to another step. So now I will check which one is minimum. Here one is minimum, right? So what will I do is I will check whether this one is greater than left max. Yeah, so I will reassign my left max as 1, and I then move my left pointer to next step. So I'm moving my left pointer to next step, and now I will check. Here you can see both are equal, so in that case you can either go with right or left, but as I already said, I go with left. So I move my so I will move my left pointer. Before moving, I will check whether the value which is currently I am in is greater than left max. Yeah, of course. So what I will do, I will change my left max to 2, and then I move my left pointer. So now here you can see I will again check my left and right pointer. In this case, you can see that left pointer having the low value. So I will check whether the left pointer value is greater than left max. No. So I what will do? I just subtract with the left max, and I increment in the result, and I then move my left pointer to another step. I think you understand so far. So now I will again check. Here again 0 is the minimal one, and I check with the left max, but it is less than left max. So what I will do, I subtract with the left max. So left max is 2, so 2 minus 0, which is currently we are in 0, so I am subtracting 2 with the 0, so I get 2. So in this index there will be a chance of storing 2 water. So I increment that value to the result, and I then move my left pointer to next one. So here you can see again the left pointer having the low value than the right pointer. So what I will do, I will check with the left point. I will check with the left max. As you already see, the left max is 2, but it is less than 1. So what I will do, I will do same thing, that is subtracting with the left max, and I will move my left pointer. So now you see the right having the low value. So in that case, I will check whether this right value is greater than right max. No. So what I will do, actually this value is greater than right max, right? So what I will do, I will reinitialize my not reinitializing, I will update my right max to these particular index which is currently I'm in, just 2. I'm change my right max to 2, and I then move my pointer to next. And now you can see again the left values higher here, right? So what we'll do, we go with the right pointer and we check whether the value which is currently in is greater than right max. No, because right max is 2, but here 1 is there, so 1 is less than right max. So what I will do is I will subtract the right max with the current index I'm in. So actually right max is 2, the current index we are in is 1. So 2 minus 1 is 1. So in this particular index 1 will be stored, as well as I update this to the result. So then I move my index, that is my left pointer, right? So I'm moving left pointer, and I will again check. Here 2 is minimum, that is right pointer is minimum, and I will check whether this value is greater than right max. No, it's equal, right? So what I will do, I will doesn't do anything, and I just move to next, that is here. Moving here, actually currently the left and right pointer is positioning in the same, right? So what I do is I just make it this like, okay, so both is pointing here. So now both is pointing here, so what means both values are same, so I will go always with left. So I am coming here. So once the left and right crosses each other, I will break the loop. So guys, I am written the code. Here you can see my code where I am initializing my left pointer to 0 and my right pointer to the end of the index. Okay. So this is the thing. My left max initializing I am with 1, sorry 0, and right max as 0. either 0 or -1, does not a matter. And I am doing the condition which I already said. So this is complexity of order of n. Okay, so just I am returning my result. So first let's run the code. So it's compiling. So let's see. So we get the correct output. Now we'll submit the code. We can see what happened. So here you can see success. So this is a simple problem. Even though they are saying this is as a hard, if you understand the concept behind this, it would be very easy. Okay, so that's all today. Thank you for watching. Thank you all, guys.